SM Vundla, and welcome to Geography Tutorials. Right, today we'll be looking at the magnetic bearing. Right, what is a magnetic bearing? Magnetic bearing, have a lot of definitions. One would say it is a true bearing plus a magnetic declination. One can say it is the combination of a true bearing and the magnetic declination. Right. Okay, if you have any definition, just write it on the comment section, then I will check it for you. Okay, today we're looking at the magnetic bearing. If we're taking note of this word, magnetic bearing, it is made up of two terms. Which are those terms? Term number one is the magnetic. Term number two, bearing. Right. We know that magnetic bearing, it is formed by two calculations, which is a true bearing calculation and the magnetic declination calculation. These two are independent calculations. So what is a bearing? Bearing, it is the distance in degrees from point A to point B, or from one point to another point. Right. What is the magnetic declination? On this map of mine, magnetic declination is placed far right. Yeah, this is the magnetic declination. Right. So what is the magnetic declination now? Magnetic declination, it is what? It is the angle between true north and magnetic north. Right. Okay, so as we know the difference between magnetic declination and true bearing, and also a magnetic bearing. Right. So before calculating magnetic bearing, you will have to calculate the true bearing as an individually or independent calculation, and also know how to calculate a magnetic declination as an individually or independent calculation. That is what we are going to do today with Mr. Vundla. Right. This is a topographic map of mine. Let's start with the true bearing. Let's say you are given a question like this. Calculate the true bearing from a Trick Bacon 26 at D7 to spot height 1786 at E8. Here, let's look those points on this map of mine. Point number one, it's D7. Moving to D7 here. Trick Bacon 26. Do not mind that we've already have a cross section. So when calculating a true bearing, you have to know that step number one, you have to have this thing, this tool, important instrument, which is a protractor. Right. Tool number one. Step number two, what you have to do, you have to note the weight from on a question. Here they say from Trick Bacon 26. We're looking to Trick Bacon 26. On the area or on the point from, you draw what? A cross section with your lead pencil. You draw a cross section which will divide your angle into two. You know? Right. After doing a cross section on that point from, you note another point which is 2. Then you draw a straight line joining these 2 points. What are we joining? We are joining a Trick Bacon 26 and the spot height 1786. Right, let's join them with a pencil. There we go. Now we have these points. We have joined our points. So what is our next step? The next step says again, you have to know the rules of calculating the magnetic declination. Take a look at this thing. This is a protractor. So the rules are, rule number one says your protractor will always faces to your right, which is my left hand side if I'm facing you. So whenever calculating a true bearing, your protractor must face to the right hand side. From your point, you place your protractor at the center of the point from, and faces the C-shaped side of the protractor must face to the right or eastwards. Okay, I hope you are taking some notes there at home. Right, if there's anyone who have some queries or questions, just click on the comment section and feel free to list your questions or queries. Right, when placing your protractor at the center, what you will do, you will now start calculating the degrees from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 1, 2, 3. So, our point 2, we find it on 162 degrees. Then you go write it down. So, this tells us that our TB, which is true bearing, equals to 162 degrees. Right. This is our final answer of a true bearing. But if now we were told calculate the true bearing from 1786 E8 to the trick beacon now, not from the trick beacon to spot height. Now we are from the spot height to the what? To the trick beacon. What you will have to do is that now you draw a cross section on a point from, and then you draw a line joining them. So let's draw it now on this side. On this side, right. Now we have the cross section on the spot height. We are going to what? To the trick beacon. If we're looking at this, the spot height is on your right, and the trick beacon is on the left. What does that have to tell you? That means already we have what? 180 degrees already. Why now? Because always we place the protractor faces what? To the east. So if we place the protractor to the east, from 0 to 108, we haven't reached our point. What does it tell you? It tells us that we already have 180 degrees. Then we have to turn our protractor until we reach the point of a trick beacon. Do you all understand? Okay, then we turn our protractor from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, 30, 40, 160. Then we reach our point at 160 degrees. What does it tell us? We already have what? 108 degrees plus 160 degrees. You know, that makes what? 340 degrees. Alright, so just know that if the point is on the left, you will have to turn your protractor clockwise. If it is on the right, then you will just place your protractor facing east and you'll get your answer. This is how we do the true bearing. And this is the final answer of our true bearing. Right. Number 2. Now let's move all together to the magnetic declination. Let me just check the comments and see if there's no one who missed or okay, no, let's continue. The magnetic declination. This is the most easy calculation on the network. Magnetic declination, what you have to know, it's only the steps. So this is our magnetic declination. Far right. Okay, so the arrow, the longest arrow, it is called true north, and the slanted or diagonal arrow, it is called magnetic north. So what it says here, it says mean magnetic declination 25 degrees 51 minutes west of true north. And I hope you are writing down. Then in brackets it says May 2018, then full stop. Mean annual change, it's 9 minutes westwards. Then we have another 2 dates that is in brackets, all in brackets. Right. On every geographic calculations, it has its own rules. Here, my tip to you, whenever writing a test on Excel, what you have to do, on the magnetic declination, we've got 3 dates or map dates, but we are not using all of them. So, on every magnetic declination map dates, we only use the map that is isolated, or the map that is placed alone, not placed with other dates, you know. Right, here, let's do here. Which map is isolated? It is May 2018. Why? These 2 map dates, we do not use them. You can just cancel them with your lead pencil or your pen. Right. Okay, let's go through the magnetic declination calculations. The magnetic declination calculation. Magnetic declination calculations. Right. Hope we are still together. Hopefully we are still together. Right, here is our magnetic declination. So, step number 1, it says calculate difference. DF stand for difference in years. If you are not given the year we are calculating, you have to use the current year, the year that you are in. Also here, because we are not giving the year to calculate for, we're gonna use what? The year 2023. So they say calculate difference in years. We use that map date 2023 current year minus the map date, which is what? 2018 minus 2018. What does that give us? It gives us 5 years difference. It is 5 years. So we know that difference in years, it is 5 years. Right. Number 2, step number 2 says we multiply our mean annual change by difference in years. How do we get a mean annual change? Just note that mean annual change and the magnetic declination, it is always written on your map. So here it is written mean annual change. It will always written like this. Mean annual change, it is here, it is 9 minutes westward. So step 2, they say multiply mean annual change by with difference in years. So we say 9 minutes west multiplied by 5 years. Then we get 45 minutes. So your answer will be in what? In minutes. 45 minutes westwards. Right. Another thing that we have to take note on the magnetic declination, it is the direction. If we are moving westwards, what do you do to the minute? You add the minute. If you are moving the direction to the east, what do you do to the minute? We subtract the minute. So here we moving to the west. So what we add? Right. Step 3 says magnetic declination. So we write the magnetic declination as it is from the map. Here, this is our magnetic declination. 25 degrees 50 minutes plus 45 minutes west. What does that give us? So 50 plus 45 minutes, that it is equal to 25 degrees 95 minutes west. So this is our new mean magnetic declination. But the magnetic declination rule says if we must not have minutes more than 60, here on the minutes. If we have them, we have to subtract the minutes and convert them into degrees. Just know that 60 minutes equals to 1 degree. Therefore, automatically 1 degree equals what? 60 minutes. So here we must have 60 minutes or less. If we have more than 60 minutes, we are forced to subtract 60 minutes and convert it to degrees. So 95 minus 60 minutes equals to 35 minutes. Right. So now we know that we're subtracting 60 minutes from these 95 minutes. We are left with 35 minutes. So now, what we have? Know that for every 60 minutes that you subtract, changes and become 1 degree. So we add that 1 degree to 25. So now what we have now equals to 26 degrees and 35 minutes. This is our magnetic declination. This is the end of calculation of magnetic declination. Know that again. If we now have the true bearing and the magnetic declination, we can now know our magnetic bearing. Alright, so we have to unpack our calculations, right? So now we have our true bearing, we have in magnetic declination. So we've said before, to get a magnetic bearing, you need to know true bearing as an individual or independent calculation, and know what? The magnetic declination as an independent calculation. So now we know that our magnetic declination equals to 26 degrees, 35 minutes, and our true bearing equals to 162 degrees. So let's write down the formula of calculating the magnetic bearing. Magnetic bearing equals to, let me write with a different color, the magnetic bearing. So the magnetic bearing equals to true bearing plus magnetic declination. Right. So what is our true bearing? We have calculated it before. It's 162 degrees. We write 162 degrees of our true bearing. And now, what is our magnetic declination? It's what? It's 26 degrees, 35 minutes plus 26 degrees, 35 minutes. Now, what does it tell us? Degrees are added to another degrees. Alright, so 162 degrees plus 26 degrees is equals to 188 degrees, 35 minutes. Right, so the minutes, they remain the same because we only add degrees to their what? To other degrees. So this is how we calculate what? The magnetic bearing. I hope you've enjoyed this lesson, and if you have any questions, just feel free to write them, or any calculation, write them on the comment section. Then we'll meet on our next tutorial. Thank you.